So I talked about sound intensity in the very first video and talking about the loudness of the sound wave. And this is one of the ways that you can measure sound intensity. So this particular one using the decibel scale is known as sound intensity level. So I will just sort of append this as sound intensity level. So sound intensity level is measured in decibels, whereas sound intensity in the other form is actually measured in watts per square meter. Now the cool thing about loudness of a sound is that it's naturally logarithmic, and it is actually base 10 logarithmic. And you can actually show that if this intensity is doubled, then there's an increase of 3 decibels. So the scale of increase in decibels would be linear, but the intensity has to grow by continual factors of 2 each time. Now the formula for this, as you can see, the intensity beta is given as 10 times log to the base 10 of the intensity divided by I0. Now I0 is known as the threshold of hearing, and it's given as 1 by 10 to the minus 12 watts per meter squared. So the intensity for this is given as watts per meter squared, and it can be converted into decibels by using this formulation. Now another way to measure intensity is, as I said, using watts per meter squared. And this is often a fairly straightforward one to calculate in comparison to using base 10 logarithms. So the intensity is the ratio of the power exerted by that source to the area. Now we'll assume that the power is constant and it's not varying for sort of particular tracks, for example, because some notes will actually exert more power on a source than others. So we'll just assume that the power is a constant value and that the intensity and the radius vary. So because sound emanates in the shape of a circle, as you can see here in this ripple inside of a pond, the area that we're talking about is actually the surface area of a sphere, which gives 4 pi r squared, where r is the distance from the source to wherever you're standing. Now, even if looking at this formula might seem like sort of a simple speed equals distance over time formulation, but intensity actually follows the inverse square law. Because if I was to rewrite this particular equation, substituting in the proper area, we'd get I is P over 4 pi r squared. So you can show that the intensity is inversely proportional to the distance away. Now we'll use both of these formulas in 2 examples, which I will do in the next 2 videos.